Good day everyone, my name is Ting from Maths 2 and today I would like to be presenting my individual alternative solution for non-routine mathematical problem using graphical representation as my chosen method. This presentation follows Polia's 4-step problem solving model. The non-routine question. A local art teacher is preparing for a mathematical sculpture exhibition and designed 4 miniature sculptures made of different materials. A bronze cube, a marble sphere, a glass cone, and a clay pyramid. Since each material has a different density and size, their weights are not the same. To pack them safely for transport, she used a digital balance to compare their weights and records the following result. First, 2 cubes and 1 sphere balance 1 cone and 2 pyramids. That is 2c plus s equals to n plus 2p. 1 cube and 3 cones balance 1 sphere and 2 pyramids. That is c plus 3n equals to s plus 2p. Last, 2 pyramids and 1 sphere balance 3 cubes and 1 cone. That is 2p plus s equals to 3c plus n. After taking this measurement, she discovers that the marble sphere weighs exactly 6 grams. Based on this information, determine the weights of each sculpture before packaging. Polia Step 1. Understand the problem. The non-routine problem involves determining the weights of 4 sculptures: a cube, a sphere, a cone, and a pyramid. The relationship between weights are known, since the art teacher balanced them in different combinations, giving 3 equations. 2c plus s equals to n plus 2p, c plus 3n equals to s plus 2p, and 2p plus s equals to 3c plus n. And we know that the sphere weighs exactly 6 grams. Therefore, the task is to find the weights of c, n, and p by using a graphical approach to show it. First, write the 3 equations by substituting s equals to 6. 3c plus 6 equals to n plus 2p. c plus 3n equals to 6 plus 2p. 2p plus 6 equals to 3c plus n. Then simplify into standard form. Ax plus by plus cz equals to d. Therefore, 2c minus n minus 2p equals to negative 6. c plus 3n minus 2p equals to 6. 3c plus n minus 2p equals to 6. Then, rename the variable x. X equals to c, y equals to n, and z equals to p. Then the equation represents 3 planes. 2x minus y minus 2z equals to negative 6. X plus 3y minus 2z equals to 6, and 3x plus y minus 2z equals to 6. The goal is to find the intersection point x, y, z, which satisfies all 3 simultaneously. Polia Step 2. Devise a plan. Instead of solving algebraically, I choose to visualize this equation as plane in 3D space using GeoGebra 3D graphing. The intersection point of these 3 planes represents the exact combination of values for c, n, and p, thus satisfy all equations simultaneously. Why graphical representation? Visualize the relationship between variables. Demonstrated clearly that the solution is the intersection point of the 3 planes. Strengthen conceptual understanding of simultaneous equation in 3D. Polia Step 3. Carry out the plan. First, input the equation in GeoGebra 3D. Type the 3 equations. 2x minus y minus 2z equals to negative 6. X plus 3y minus 2z equals to 6. 3x plus y minus 2z equals to 6. The diagram shows the 3D visualization generated in GeoGebra. Each color plane corresponds to 1 equation. Identify intersection. Where the three planes intersect, that single point represents the solution to our problem. Therefore, we can use the intersect tools. First, let F be intersect to equation 1 and equation 2. G intersect equation 1 intersection 3. And the intersect line F and line G. Therefore, GeoGebra calculated the intersection point as 4, 4, 5. This means cube and cone weighs 4 grams. The pyramid weighs 5 grams, and the sphere is given as 6 grams. Polya step 4. Look back. First, verification. To verify the accuracy, substituted the value into all the three equations. And we get that left-hand side is equal to right-hand side. The all conditions satisfied show that the graphical result is correct. Interpretation. By looking back, we can conclude that the three planes intersect at exactly one point. This means our measurements are consistent and have one unique solution. If the planes didn't meet at a single point, it would mean inconsistent or inaccurate data. The graph also reveals an interesting relationship. The cube and cone have the same weight of 4 grams. This suggests symmetry in the sculpture design or density. The pyramid and sphere are slightly heavier, following the expected material differences. Reflection. I choose the graphical representation because it gives a visual understanding of how the equation related geometrically. It helps us see that simultaneous equations can describe spectral relationships, bridging algebra and geometry in a clear visual way. Possible improvement. Regressions, planes, or least square may be used to estimate an intersection region if real-life data has minimal error that links to statistic and measurement errors analysis, which is an extension concept for further research. Through this method, I learned that mathematics is not only about solving equations, but also about interpreting relationships visually. It made me appreciate how technology like GeoGebra can transform abstract algebra into clear, meaningful visuals. That's all from me on the graphical representation of the sculpture weight problems. Thank you for listening.